In this video, we will learn about a significant category of surfaces known as cylindrical surfaces. Up to now, we've studied vectors and vector operations in three-dimensional space to describe lines and two special types of surfaces, planes and spheres. In this video, we introduce a third type of surface in space called a cylindrical surface, or simply a cylinder, because cylinders are the next surfaces after planes in order of complexity. Please don't forget to click on the like button, subscribe to our channel and activate the notification bell. Your support is crucial for our channel's growth and enables us to continue creating quality content. Thank you in advance for your support. In everyday language, we use the word cylinder to describe the surface that forms, say, a hollow pipe, a soda straw, or the curved wall of a paint can. In mathematics, the word cylinder has a more general meaning. A cylinder is a surface that consists of all lines called rulings that are parallel to a given line and pass through a given plane curve called the generating curve or directrix. In other words, the term cylinder refers to a surface that is parallel to a line. With this definition, many surfaces qualify as cylinders. To understand what these surfaces are, let us start drawing a plane curve in the xz plane. This curve is the generating curve or directrix for the cylinder. We then draw a fixed line that passes through the directrix but is not parallel to the xz plane. The surface of the cylinder is created by moving a straight line along a given plane curve while keeping the line parallel to a fixed line. The set of lines that are parallel to the given line and pass through the given curve forms a cylindrical surface. In this example, the rulings of the cylinder are parallel to the y-axis. It's important to note that any curve has the potential to form a cylindrical surface, and the rulings that make up the cylinder can be parallel to any given line passing through the given curve. The term cylinder typically brings to mind the image of a right circular cylinder or a hollow pipe. In the following example, we will demonstrate that the definition of cylinder applies to the well-known right circular cylinder or a hollow pipe. We begin by drawing a circle in the xz plane, which will serve as the directrix for the cylinder. Then we draw a fixed line that runs parallel to the y-axis and passes through the directrix. The surface of the cylinder is generated by moving this line along the circle while ensuring that it remains parallel to the fixed line. The set of all lines that are parallel to the fixed line and intersect the circle forms a right circular cylinder. Equations of cylinders. The equation of a cylinder whose rulings are parallel to one of the coordinate axes contains only the variables corresponding to the other two axes. In short, if one of the variables x, y, or z is missing from the equation of a surface, then the surface is a cylinder. Let's see how it works. This equation represents a circle with radius 3 in the xz plane centered at the origin. So we begin by sketching the graph. Since y is missing, The rulings of the cylinder are parallel to the y-axis and allow y to take on all real values. Well, if you have to draw by hand, I suggest you make two lines parallel to the y-axis and tangent to the circle. When we are dealing with surfaces, it's important to recognize that an equation like this represents a cylinder, not a circle. In the xy plane, this is the equation of a parabola with vertex at the origin that opens in the positive y direction and is symmetric about the z-axis. We begin by drawing the parabola. Since z is missing, the rulings of the cylinder are parallel to the z-axis and allow z to take on all real values. First, we need to identify the shape of the equation. In this case, if we divide both sides by 4, it becomes clear that this is the equation of an ellipse. Since z is missing, the rules of the cylinder are parallel to the z-axis and allow z to take on all real values. The axis of the cylinder is the z-axis. The surface is called an elliptic cylinder. The surface is a hyperbolic cylinder with rulings parallel to the y-axis.